Okay guys, what's up? Again, I'm Sir B and we're back to discuss another problem for the topic of a portal analysis. So for this problem, this is a combination of a portal and analysis of truss. So for this problem, determine the force in each truss member and also find the reaction at the fixed column support at A and B. So you have here an external applied load of 12 kN acting at joint F, which is going to the right. And 2 meter below that, you have an 8 kN acting at point G, which is also acting to the right. Okay? So, each span of the truss is measured as 1.5 meter. And the height of this column is 6 meters. Okay guys, so the first thing that we need to do is to determine the shearing force acting at this column. At the same time, hanapin na rin natin yung actual force niya by using moment either of these 2 points. So again, these are external column. There's no internal column. Therefore, ang hanapin lang natin is yung shearing force, which is equivalent to V only. Okay, or 1. Okay, so para mas maunawaan, i-drawing ko lang yung free body diagram and balikan ko kayo. Okay guys, so ang ginawa ko, nag-section ako dito sa gitna ng column na to and I consider that as my section 1. So in-isolate ko siya and ito yung makikita mo dun. So, again, ang assumption natin lagi, di ba, sabi sa portal method, laging kalahati ng bawat member. So, ang ginawa ko, kinuha ko yung 3 meters niya, and then ito, 2 meters. And the rest, kinapi ko lang yung mga values dito sa taas. Okay, so pangalanan natin yung mga internal forces dito sa column na ito. So, again, this is an external column, so no need to consider the internal column or yung 2V from our previous example. So, this is your shearing force, denoted by V. Or ang gawin natin, this is the shearing force for the column AG. And this one is the shearing force for CB. Kung saan, sabihin natin na sila ay parehong equals lang sa X. And with that, the value of VAG and VCB is just the same. Okay. So next, alamin natin yung magiging direction ng kanyang actual forces sa column. Okay. So assuming this is a point, itong dalawang to, dito sa gitna ng column. So in order to counteract this, halimbawa, magmo-moment tayo dito sa point na to. So itong 8 kN and 12 kN will produce a clockwise moment. So to prevent the frame to toppled over or tumaob, so di ba ang ikot niya is pa ganun, so dapat itong actual force dito sa column na to is pasaan yung direction para ma-prevent yung pag taob ng iyong frame. So dapat ito makapag-produce ng counterclockwise moment. So ito is dapat magiging pababa. And let us name this force as the actual force for the column AG. Okay. So considering the forces vertical, so ang mangyayari, itong dalawang actual force na lang na ito ang magiging forces Y or acting in a vertical direction. So if this is acting downward, therefore ito magiging pataas na siya. Okay? To make it in equilibrium. So this is the actual force acting at the column CB. Okay? So, unahin natin i-solve yung value ng shearing force. Okay? So, ang mangyayari lang, let's just take summation of forces X or summation of forces horizontal. So, assuming to the left as positive, so we have 2X, since dalawa to, 2X is equals to the sum of 12 and 8, which is equals to 20 kN. Therefore, the value of X is equals to 10 kN, or the value of shear AG is equals to the value of the shear CB, or that is equals to 10 kN. Next, magmo-moment tayo either from this point or this point to get the value of one of the actual forces. So, ang gawin ko na lang dito ako mag-moment, okay? Therefore, assuming that counterclockwise moment as positive, assuming moment, let's just say that this is point A, B, C, D, E, F, G, H, I. So, let's just name this as point J, okay? So, by taking summation of moment at point J, assuming counterclockwise moment as positive, sorry. So, therefore, A, or the actual force AG, multiplied by the distance na 6 meters. So, counterclockwise. So, ito clockwise na. Transpose to sa kabila to make it in positive. So, 12 multiplied by this distance. So, 2 plus 3 or 5. And then plus 8 multiplied by the distance of them. Therefore, we will have a value for AG. So, pindutin lang sa ating calcu. So, that is 12 times 5 plus 8 times 3. And then divided by 6. Or that is equals to 14 kN. And then, kapag nag-summation ang forces Y, so since dalawa lang naman yung vertical forces, so the value of your actual force for GB is just equivalent to actual force of AG, or that is also equals to 14 kilonewton. Okay guys, so next, ang gawin natin, since meron na tayong mga actual forces dito, we can now solve for the values of the reactions at the fixed support at the bottom. So, next, ang gawin natin, consider natin again yung section 1, but this time, ang consider natin is yung bottom part. So again, i-drawing ko lang to make the length of this video shorter. Okay, so again, considering the section 1, but the bottom portion, so ilalatag naman natin ngayon yung mga values ng shear and the actual force at each column. Okay guys, so kung ito is pakaliwa dito, therefore, kapag nilatag mo siya dito, magiging pakanan na siya. So that will have a value, so AG as 14 kilonewton, as 10 kilonewton. So as for this column, so labelan na natin to. So this is A, and this is B. So this is also equivalent to 10 kilonewton. And the height of this, since mid-height nga siya, so that will be 3 meter. Okay, so yung actual force mo dito is pababa. Therefore, pagdating dito, magiging pataas siya. So the actual force AG has a value of 14 kilonewton. And dito, since pataas siya, so dito naman magiging pababa. So that is also equivalent to 14 kilonewton. Okay, so kung ito is papunta dito, therefore the reaction here should be going to the left. So siguro alam niyo na yung value ng let's name this as RAX. So titigan niyo na lang, kitang-kita naman na yan ay equals lang din sa 10 kilonewton, and then since ito pataas, therefore dito magiging pababa. So let's name that as RAY, which is also equivalent to 14 kilonewton. And yung RBX mo dito, so by inspection alone, so kung ito'y pakanan, so dapat ito pakaliwa din. So RBX, which is equals to 10 kilonewton, and then since pababa yan, so dapat dito pataas yung RBY, which is a value of 14 kilonewton. Okay, next, the moment. So ang magproduce ng moment mo dito is itong 10 kilonewton, which will produce a clockwise moment. So to counteract that clockwise moment, dapat yung moment A mo dito is counterclockwise. And the value of that is equals lang sa 10 multiplied by the perpendicular distance na 3, or equals to 30 kilonewton meter. And then, ganun din kay moment B. So dapat to counteract this clockwise moment, so dapat pa counterclockwise siya. So moment B is also equivalent to 30 kilonewton meter. Okay, so these are the answers for the first question. What are the reactions for the fixed column support? So we're done with that. Next, we will now solve for the values of the forces at each member. So again guys, i-drawing ko lang muna para mapababa natin yung length ng video. Okay, so guys, kung mapapansin nyo dito, ang ginawa ko kasi dito, nag-cut ako dito para mahanap natin yung mga values dito sa member FE, FH, and GH. But as you can see here, I consider section 1 and section 2. So, di ba nag-section tayo dito kanina? Ang ginawa ko, kinonsider ko rin yung cutted portion na yun. But pwede rin naman, na section 2 lang yung consider natin. Kaso ang mangyayari, yung i-consider mo are the reactions dun sa support A, which is mas marami since meron kang moment. But then again, ito naman mga values na to is nanggaling lang din dito. To sa shearing force sa column and din sa actual force na yun. Actual force na column na yun. So ginawa ko na lang para at least kaunti lang yung variable na i-consider natin. Ang ginawa ko, kinonsider ko rin yung section 1. But then again, same lang ng answer yung lalabas. Ang mangyayari lang, mas marami yung i-consider mo na variables dito kasi may dadagdag ka ng moment. Okay? So wag malilito, ang ginawa ko lang, consider section 1 and then this section 2. And consider the left portion. So ito yung lalabas niyan. Okay? So, ganun lang. Balik tayo sa static of rigid bodies. Moment ka lang ito. Analysis of a truss. Considering sectioning method. Okay? So, anong unahin natin? Okay, tama. So, ang pwedeng gawin natin dito is mag-take tayo ng moment sa H. Sa point H. Kung saan magiging concurrent itong FH, remember FH, and GH. So, ang mahanap natin dito is yung force for member FE. So, moment tayo dito sa point H. So, saan ko pwede sulat? So, dito na lang. Dito ba sa taas? Wait lang Okay. So, when we take summation ng moment, taas ko lang natin. So, when we take summation ng moment at point H, which is equals to 0, so, clockwise positive. So, FE multiplied by 2. And then, so, equals, so ito, saan nga tayo? FE. So in 12, magiging minus since clockwise din siya. Nilipat ko sa kabila. So 12 times 2. Yung 8 mo naman is concurrent, tatama sa H. So, don't need to consider this. So, yung 10, magproduce din ng clockwise moment. So, minus 10, multiply by the distance of 3. And then yung 14, so that will produce a counterclockwise. So, since 3 non-supposed sa kabila, magiging positive. So, plus 14 multiplied by the distance of 1.5. Okay, so with that, we will have a value of Fe, which is equals to, so negative 12 times 2, minus 10 times 3, so plus 14 times 1.5, and divided by 2. So the answer is negative 16.5. Ibig sabihin, hindi siya dapat tension dito. So again, you have two options. It's either panghawakan mo negative siya, wag mong babaguhin yung sign. Negative sign indicates na siya ay compression dapat. Or, gawin mo siyang 16.5 kN positive, kaso gawin mo na siyang compression. And then, from this, i-correct mo na yung direction niya. Okay lang ba? Okay, so next, ano ba magandang gawin dito? Maganda na lang tayo, summation ng forces X and forces Y, okay? So, unahin natin yung summation ng forces Y. So, since between these two members, ang meron lang Y component is si FH. Tama? So, kapag nag-summation ng forces Y, mahanap mo yung value ng FH, and then, once we get the value of FH, we can now solve summation of forces X to get the value of GH. So, hanapin muna natin yung ano nito, slope. So, this is a slope of, vertical mo is 2, the X mo is 1.5, so yung slope mismo is 2 squared plus 1.5 squared, or that is equals to 2.5. Okay, so meron na tayong slope. So again, take summation ng forces ng Y. So assuming downward direction as positive equals to 0, so we have FH, then multiply mo ng slope. So to get the Y component, 2 times 2 over 2.5. And then, ano pa ba ang Y forces mo? Ito, ayun, mali rin ang assume natin. So pababa rin siya, so minus 14, or FH should be equals to 14 times 2.5 divided by 2. Or that is 17.5. So again, negative siya, or 17.5 kilonewton. So therefore, this should be also a compression force. So gawin mo na lang, gawin mo siyang compression, and then baguhin natin yung direction niya. Okay, so next, this time, to solve the value for GH, so just take summation of forces X. So assuming to derive forces as positive, so the equation will be GH is equals to, so FH, positive siya since papunta sa kaliwa, FH times 1.5 over 2.5, and then plus 16.5, ano pa ba? And then ito, so plus 10, and then ibaba ko na lang dito, so minus 12, then minus 8. But if H yung sinunod ko dito, so 17.5 to so the GH will have a value of 17.5 times 1.5 divided by 2.5 plus 16.5 plus 10 minus 12 minus 8. Okay, so the values of your GH is equals to 17 kilonewton. So that is correct. So siya ay tension. Okay guys, so next we will consider this section 3. So again, drawing ko muna yung figure to reduce the length of this video. Okay, next, we will now consider the section 1 and section 3. So itong cutting section naman na to, and considering also the section 1. Again, para consider na lang natin is yung shearing and yung axial force sa column. Okay, so for this, you have several options. Ang pwede mong gawin is, ilocate mo yung point kung saan magiging concurrent sila, which is at joint E, to eliminate this member FE and HE. But since we have a value of FE, which we have solved earlier from section 1 and section 2, para mas madali na lang yung solution natin, pwede nga gawin natin dito is mag-summation na lang tayo ng forces Y and summation ng forces X. So unahin natin yung summation ng forces Y to get the value of your HE, and once we get the value of HE, we can now solve for the value of HI using summation of forces X. Nasulat lang natin yung equation dito. So assuming upward direction as positive, take summation of forces Y equals to 0. So the equation will be HE multiplied by 2 over 2.5. Same slope lang din naman sila. And then equals, so pataas, ito pababa. Meron pa bang Y forces? Wala na, no? So equals to 14. Or HE is equivalent to 14 times 2.5 divided by 2. So that is equals to 17.5. So that is positive, therefore that is correct na tension siya. And then next, to get the value of your member HI, take summation of forces X, assuming all to the right forces is positive. So HI is equals to, so yung HE mo, is papunta rin yung sa kanan yung X component, so that is 17.5, kaso negative siya. 17.5 multiplied by 1.5 over 2.5 to get the X component. And then plus, ito pa ganun din, pa kanan, so minus 12, minus 8, and then pakaliwa, transpose sa kabila, positive, so plus 10. Okay, may nakalimutan ba? Oops! Muntik na makalimutan si FE. So ang FE mo has a value of 16.5. So pakaliwa rin siya, so that is also equals to positive. So therefore, HI is negative 17.5 times 1.5 divided by 2.5 minus 12 minus 8 plus 10. Hindi na ganito. Plus 10 plus 16. Negative 4. Pindutin ko lang ulit ha. Negative 17.5 times 1.5 divided by 2.5 minus 12 minus 8 plus 10 plus 16.5. So negative 4. Okay, so again, negative 4 indicates na mali lang yung naging assume natin. So instead of tension siya, dapat pala siya ay 4 kilonewton kaso compression. So, ang gawin mo na lang, correct mo na lang agad dito. Okay, so next will be joint. Pwede na tayo ngayon mag-joint E. And then after E, talon tayo dun sa joint I. So, since we know these two values, pwede na tayo mag-joint, method of joint. Since dalawang member na lang yung hinahanap. Okay? So, drawing ko muna yung joint E natin. So, at joint E, gawa ka lang ng X and Y plane. So, ilatag mo yung force. Ano nga yung FE natin? FE is in compression. FE. So, HE, so tension. Which is pababa. Tension, 17.5. Okay, so, ang mangyayari dito, sinulat ko ng diretso. FE, 16.5 na natin dito. 16.5. Okay, so slope is given as 2, 1.5, 2.5. Okay guys, so analyze natin mabuti. Paano ba natin i-assume? So, considering the Y component of the force, so merong ang pababa. So, dapat ito, pataas. Okay, so this will be the direction of your EI. And then, considering the X component of the force, dalawang force na ito, which is going to the depth, so para matulungan tong FE, so assume ko na paanan yung ED. Alright. So, either of the two, summation ng forces X and forces Y, mako-compute mo naman yung hinahanap. No. Unahin natin yung summation ng forces Y, kasi nga, ito lang yung merong Y component. Okay, so ganun na, method of joint. Take summation of forces ng Y equals to 0. So we have EI, assuming upward is positive. So EI multiplied by, unsell din pala. Anyway, sulat na lang din natin. 2 over 2.5 is equals to 17.5 times 2 over 2.5. So same slope din naman yan. Kaya sinabi ko kanina na unsell. Or EI is equals to 17.5 kilonewton. So tama na siya ay compression. Next, by taking summation of forces X equals to 0. So the equation will be ED to the right as positive. So equals natin, ano ang EI mo? 17.5. So parang 17.5. So multiply ko na lang ng 2. 17.5 to get the X component multiplied by 1.5 over 2.5. And then minus 16.5. Okay, so we have the value of ED, which is equals to 2 times 17.5 times 1.5 divided by 2.5 minus 16.5. So that is 4.5 kilonewton, which is in tension. Correct yung assumption natin. So we're done with these members. Ano pa ba? Ito, and ito. Okay, next will be joint I. So, lagyan ko lang dito ng partition. Ayan, nilabelan ko pala yung step by step. Gawin nga natin ng star. So, this is step 5. So, we will now consider joint I. So, at joint I. So, again, draw the X and Y plane. And then, ilatag mo yung mga known forces, known value. So, we have EI. Ano nga yung EI natin? 17.5, which is in compression. So, this is 17.5. Again, given ang slope na 2, 1.5, 2.5. Aside from that, we have HI. Where are you, HI? Eto, so 4 kN, so compression din. Okay, so, paano ba? So, kung ito pababa, yung Y component, so dapat ito, pataas yung Y component, or tension yung magiging assumption natin. So, this is ID. And then, since lahat ng force, X component is papunta dito sa kaliwa, sa kanan, tama, papunta lahat ng kanan. So, dapat ito, maging pakaliwa. So, this is IC. Okay, so unahin natin yung summation of forces ng Y equals to 0. Assuming upward direction as positive, so the equation will be ID multiplied by 2 over 2.5 is equals to 17.5, cancel ulit, 2 over 2.5. Tama? So, cancel, ID is 17.5 kilonewton. So, tama na siya, I in tension. And then, take summation of forces X, assuming to the direction as positive. So, we have IC is equals to, so, unahin natin to. So, dalawa, pareho naman 17.5 yan, so, multiply ko na lang ng 2. So, 2 times 17.5, and then, times 1.5 over 2.5, and then, plus 4. Okay, so therefore, the value of your IC is equals to 2 times 17.5 times 1.5 divided by 2.5 plus 4. Or that is equals to 25 kilonewton. Okay guys, so we're done with these two members. So the last will be for member CD. Eto, so mag-joint D ka na lang. So at joint D, ano makikita mo dyan? So we have ED na 4.5, so that is in tension. And then you have ID. ID is also in tension. So, si CD na lang. So, ang Y component mo lang is yung 17.5 since pababa yan. Therefore, ito is dapat pataas or in compression direction. Okay, so just take summation of forces ng Y equals to 0. So, assuming upward direction as positive, so CD is equals to 17.5 multiplied by, so 2 over 2.5. Or the answer is equals to, so 17.5 times 2 divided by 2.5. Or that is equals to 14 kilonewton. Okay guys, so nahanap na natin lahat ng required. So these are your final answer. Pakikahunan na lang. Sperma nyo sa tabi kung sa exam ko man lumabas yan. Ito. Okay. Or kung gusto nyo, para mas malinis lang yung solution, gawa kayo ng table. Tabulate nyo yung mga datas. Okay guys, so for our next problem, we will discuss all about the cantilever method. Okay, so since nakita ko na naman yung notes ko, may step-by-step process lang yon, guys. So sundin nyo lang yon, kakabisaduhin nyo. Again, the solution is very easy, kaso napakahaba lang din, kagaya ng portal method. So yung previous example, ang binigay ko lang is 2-span and 2-story. Pero kasi ang mangyari guys sa problem, katulad ng example sa amin, nung college, ay, ito sinasabi ko, 2-span, 2-story lang. Pero kasi ang gawin ko sa exam, ito ginawa ko before, ito yung example sa amin. So, pwede kong gawin, pag medyo mabait-bait ako, ayan, dagdagan pa natin dito. Tapos gawin natin dito na butas. Wala itong column na to. Ayun. So, imagine nyo kung gaano kahaba yung solution dito. So again, yun naman is a matter of practice. Sundin nyo lang yung step-by-step process. I think wala naman magiging problema. Kasi before, may tumatama naman sa exam kapag ganito yung itsura. Okay, so see you guys on our next video.